Alright, what's up, Chem Bros and Chem Girls? Today we're going to be talking about dilutions. If you don't know what a dilution literally is, it's merely taking one solution and increasing the volume of it by adding usually water or some other form of solvent. To start off, let's talk about what the formula for a dilution literally is. It's simply M1V1 is equal to M2V2. M1 would be considered as the initial molarity. V1 would be considered as the initial volume. And then M2 and V2 would be basically the same things. However, you just swap initial for final. So M2 would be final molarity. I'll just denote it as capital M. And V2 would be final volume. I'll just denote it as capital V. Typically, your units are going to be molar for molarity and liters or milliliters for volume. For volume, it really doesn't matter which one you pick as long as it's the same one. That means that if your initial volume is in milliliters, your final volume needs to be in milliliters. If your initial volume is in liters, your final volume should be in liters. All right, so pretty basic formula. Let's get into an actual problem. So a 1.00 molar solution of KOH is diluted from 250 milliliters to 750 milliliters. So right off the bat, what's literally happening is we have this solution that has 250 milliliters and it's at 1.0 molar. Then what we're going to do is we're going to add water to it until the solution has a volume of 750 milliliters. So now what we want to know is, how has the molarity changed? How has that concentration changed? Luckily for us, we have a formula that perfectly does that. That's just M1V1 is equal to M2V2. If I wanted to identify everything, M1 is the initial concentration. For this case, it'd be 1.00 molar. V1, that's the initial volume, 250 milliliters. V2 is given to us also as 750 milliliters. And we're looking for our concentration. So M2 would be our unknown, what we're looking for. Now, all you have to do is just plug these values into the M1V1 equals M2V2 equation. Let me just set all that up. M1V1 is equal to M2V2. Remember that I'm solving for M2 in this case, so I'm going to make sure that it's by itself when I do the calculation. So I'm going to divide both sides by V2. Notice how V's cancel out. And so you should end up with M2 is equal to M1V1 over V2. Plug in all the values. It'll be 1.00 molar. That's M1. V1 is 250 milliliters, and then V2 is 750 milliliters. Now at this point, you need to make sure to check what unit you're going to end up with. So the actual operation for the units is going to be molar times milliliter divided by milliliter. Since you're dividing milliliters by milliliters, those are going to cancel out, and you're left with molarity. And that makes sense for us because we're looking for a concentration. So our units should be in units of concentration. As for the actual calculation of this, we're going to plug that into our calculator. It's going to be 1 times 250 divided by 750. And so our final concentration is 0.333. And remember that the units are molar. If you're wondering why I stopped at that point, for the numbers that were given to us, they were all in 3 sig figs, so 1.00, 3 sig figs. Oh, that's my mistake. It's actually 2 sig figs, because these two are 2 sig figs. So it should be 0.33. My mistake. All right, well, let's do another one. How many milliliters of water must be added to 50 milliliters of a 15.8 molar solution of nitric acid. So right off the bat, let's write some things down. We have an initial volume, that's 50 milliliters. We have an initial concentration, 15.8 molar. Let's keep reading. To have a molar concentration of 1.00 molar, and that is my last variable that's given to me, and this is our M2. So what's happening is we're starting off with 50 milliliters of 15.8 molar nitric acid. So this is my starting volume, and they're asking how many milliliters of water would I have to add to this mixture to end up with a molarity of 1.00 molar. So essentially they're just saying solve for V2. Remember that the equation for a dilution, which is what's literally happening here, is going to be M1 V1 is equal to M2 V2. Unlike last time where we were solving for M2, this time we're solving for V2. So we're going to get V2 by itself. So divide both sides by M2. And so you should end up with a formula that looks like this. V2 is equal to M1 V1 over M2. Awesome. Cool. All I got to do now is just plug in my values. M1, remember, is 15.8 molar. V1 is 50 milliliters. And M2 is 1.00 molar. Now, at this point, look at all of the things you're multiplying together and think about what units should cancel out and which units should be left behind. All right. If you thought that the molarities were going to cancel out and you would be left with milliliters, you would be correct. Look at it. You're dividing molarity by molarity. These are the only things that are the same. So these cancel out and you're left with milliliters. Another way to figure out which one you should be left with is look at what you're solving for. You're solving for volume. Molarity isn't a unit of volume. Molarity is a unit of concentration. Milliliters is a unit of volume. This is why you're looking for this one. So now I know that I just have to plug these values in. So I take 15.8 times 500 and I divide that by 1. You're going to get a crazy number. You're going to get 7,900 milliliters. So this is not the final answer, however. This is the total volume after a dilution. However, you're being asked how much water needs to be added. So we're not looking for the final volume. We're just looking at how much water is added to the solution. That's a pretty simple process. You just take the final volume that you got and you subtract it by the initial one. So you do 7,900 minus 50 milliliters, and you should get an added volume of, let's see, I can't do arithmetic math, so I'll double check, 7,850. Specifically milliliters. All right. This is also a correct answer because of the fact that this is in 3 sig figs. All of the numbers that were given to us were in 3 sig figs, so that would be the significant figures that you use. All right, let's do one last one. So 0.25 moles, not molarity, of calcium chloride are dissolved in 500 milliliters of water. Okay. What would be the final concentration after 375 milliliters of water are added to the solution? So a couple things. We have the initial amount of moles of calcium chloride. So N, that signifies moles, is equal to 0.250 moles. You have the initial volume. The initial volume is 500 milliliters. And you don't have the final volume, but you can definitely calculate it by just doing 500 plus 375. So this will give you the final volume after the dilution. Okay. Now, what they're literally asking you for is the final concentration. So our unknown in this case would be M2. But there's one other value missing. Remember that the dilution formula is M1V1 is equal to M2V2. At this point in time, I have V1, I have V2. The question is literally asking me for M2. However, I don't have M1. I don't have a way to get to that. However, it doesn't need to be given to me. I can solve for it. If you notice, you have number of moles and you have the initial volume, the amount of solvent used to dissolve said moles. Remember that the definition of molarity is literally moles of solute per liters of solution. That means that I can just plug that into the molarity equation. Remember that the molarity equation is M is equal to N over V. We have N. V just needs to be converted into liters. That's a pretty simple operation. This is going to be 0.500 liters. And now we can just plug and chug everything. So you would have 0.250 moles over 0.500 liters. Plug that value in. So 0.25 divided by 0.5, and you get an answer of 0.5 molar. Now I can go ahead and add that to the list of things that I have. So now I know that M1 is equal to 0.500 molar. And now I can actually solve for M2. So let's set that up. First, I'm going to pretty much separate it and just have it by itself. So divide by V2 on both sides. V2's cancel out on this side. And so you should end up with a formula of M2 is equal to M1V1 over V2. Now just plug in the values. M1 is equal to 0.500 molar. We just calculated that. V1 is equal to 500 milliliters. And V2 is 875 milliliters. Remember, even though I did convert our volume into liters, I'm still going to use this value just because I'm using milliliters still. If you wanted to, you could have converted this into 0.875 liters. When you plug it in, you would still get the same answer regardless. So in terms of units, it's going to be molarity times milliliters divided by milliliters. That means milliliters are going to get canceled out and you're left with molarity. Does this make sense? Well, let's look and see what unit we're looking for. We're looking for concentration. Molarity is a unit for concentration, so this does make sense. Cool. Now we just got to calculate it. So it's going to be 0.5 times 500 divided by 875. And so the final answer is we have a concentration of 0.286 molar. All right. Conceptually speaking, this answer does make sense, just in case anybody was wondering. You went from 500 milliliters to 875 milliliters. That means you're diluting it. So the molarity should obviously be lower in the end than in the beginning. So if your numbers do not make sense, make sure that you look at them. So if I got an M2 that was bigger than M1, that's a sign that I should look back and check any calculation errors that might have happened. All right, well, that's going to do it. Good luck studying, and make sure you do practice problems, because watching me do it is not going to be enough for actual exams.